0.253 milliamps. R3 is 1.8 K. Power through R4 is 36.439 milliwatts. R5 is 2.1 K. And IT is 36 milliamps. Okay. Anybody want to try to tackle this one?
Current through R1 is going to be 36 milliamps, right?
Yep. Okay, what else can we solve easy on this one? Ooh, we gotta do some calculations now. So,
Yeah, you got to do the calculations.
So let me see. Did I give us enough information? R2. Yeah. Okay. So we know. No, we don't know. We don't know that. We don't know that. Okay. Let's figure out the resistance of R1. It'll be 17.28 divided by 36 milliamps. Yep. All right. I think we're missing one more piece of information to solve this one. I don't think I gave us enough information. R4. R5. No. Okay. Let me throw another. Let me see. Let me throw a piece of information here that'll make it easy. How about if I give us the value of the voltage across R5. Yeah, the voltage across R5 is 18.897 volts. So with that, we can figure out the current through R5.
Yep.
18.897. Okay, I got 8.998 milliamps. Right? Okay, so now we know if we got 8.99 milliamps through R5, how much do we have through R4?
8.998.
Yep, 8.998 milliamps. Okay, so now if we start out with a total of 36 milliamps, 14 goes to R2, 8.99 goes to R4 and R5. How much will go through R3? It'll basically be 36.
5.255.
What'd you get?
5.255.
5.255 milliamps. Let me calculate that. 30. 8.998 minus. I got 12.749. Let me see, it'll be 36 milliamps, right? Minus, start out with 36. R2 has 14. And then we know R4 and R5 is 8. That should equals 12.749 milliamps.
749.
Yeah. Got it. 12.749 milliamps. Okay, so where can we go from here? I think we can probably solve this whole thing now. So let's start with R3. I mean R4. We have 8.889 milliamps and we got 36 milliwatts. So from that we can figure out our current or our resistance, right? So if we take 36 and divide it by 8.99 milliamps squared, it will give us our resistance. Remember, power equals I squared R. So R equals power over I squared. So let's go ahead and figure out the resistance of R4. I got something like 450 ohms.
Yeah, 450, that's what I got.
Okay, so with 450 ohms and 8.998 milliamps, what would be the voltage? So I got a basic,
4.049.
yeah, 4.049. So now if we have 4.049 volts across R4 and 18.897 volts across R5, what's the voltage across R3? Right, it would be the sum of these two, right? Or 22.964 volts. Everybody see that? Okay, the voltage across R3 equals the voltage across R4 plus the voltage across R5.
22.948.
Which means, what voltage do we have across R2? Be 22. Point.
Same as R3.
Yep, 964. Yep. So what would our total voltage be? It'll be the voltage across R1 plus the voltage across R2, right? Kirchhoff's voltage law. So we can go this way, R1 and R2, or we can go R1 and R3, or we can go R1, R4, and R5. All of those should equal the same voltage. And that should be about 40.226 volts, right? Something like that?
40.244.
Yep. Okay, what's left to do? Not much. How about the resistance of R2? 22.964 volts, 14.253 milliamps. So resistance is voltage divided by current.
Yeah.
K.
1.61 K. Who said that? Cool.
I did.
All right. And let's figure out our total resistance. So we got all our resistors. Okay. We can figure out two ways. We can use the voltage in current, or we can just figure out this way. So let's figure out by adding up our resistance. So let me see. R4 plus R5, right? Those guys are in parallel with R2 and R3. So first, we'll add R4 and R5 together. So that's 450 and 2.1 K. So that's 2.55 K. And that's in parallel with a 1.8 K and a 1.61 K. So we take the reciprocal of 2.55K, add that to the reciprocal of 1.8K, add that to the reciprocal of 1.61K, you can take the reciprocal of all of that and add that to 480. Come up with 1.1174K, something like that. And we can check it. We can divide our voltage by our current. So 40.226 divided by 36 milliamps, 1.1738. Close enough for government work.
Yeah, yeah, they're good.
That's another good thing about this chart is it allows you to easily, calculate stuff different ways to confirm your answers. Okay, that's number 8. Wow, you guys are kicking this. How about we do this? Because I'm starting to run out of gas here. How about we do number 10, and then we'll start up and we'll give you a chance to work through some of these again, and then we will go over any ones you have questions about on Monday, and then we'll start covering some new stuff on Monday. How's that sound?
Sounds good.
Okay, so let me do number 10. That one was a little fun. Kind of. All right, number 10. I was trying to be funny here. So. Okay, T, R1, R2, R3, R4. I'm using a different camera tonight. Is it nicer than the other one?
What's that?
Is the video nicer than it usually is? I got a different camera this time.
It's got a delay to it.
Okay. All right, so. Let me see. We got total R1, R2, R3, R4, R5, and R6. Got voltage, current, and resistance. Alright, we know total voltage is 48 volts. We know R1 is 847, R2 is 336, R3 is 297, 421, 697, and 880. Alright, let's see. First thing I would do is find my total resistance. Okay? Let's do this top branch first, right? We got R1 in parallel with our series of R2 and R3. So let's add R2 and R3 together. So that'll be 336 plus 297. That's 633 ohms in parallel with 847. So we'll take the reciprocal of that, 847, reciprocal of that, add them together. So that comes out, so this top branch here has a resistance of 362.264 ohms.
Yeah.
Okay, so let's go ahead and do the bottom branch now. So R5 and 6 are in parallel with R4. So we just add R5 and R6 since they're in series. So 697 comes up to 1.57K. Reciprocal of that, then it's going to be in parallel with R4, which is 421. And together comes out to 332.29 ohms for this bottom branch. So just add those two together since they're in series. Gives us a total resistance of 694.532.